Good evening students and welcome back to your chemistry class. So today we shall continue to study about the chemical properties of alkynes, right? So the first chemical property about alkynes that we are going to study is about its acidic nature. An alkyne will show acidic nature only if it contains a terminal hydrogen, like for example, if we look at this particular alkyne, right, the terminal hydrogen H is present over here, then only it is, or H is present over here, then only it is going to show the acidic character. Means one of the terminals should have hydrogen. If this is present, then also it is going to show acidic character, or if both the terminals are the hydrogen is present, then it is acidic in nature, right? For example, just now as I showed you ethyne, this shows an acidic character. Similarly, if I write down as CH3C triple bond CH, so one of the carbon terminal, it is attached with hydrogen, so this is also going to show us the acidic nature. I hope this point is clear. Now, let us see one more alkyne which does not have the terminal hydrogen. And if it does not have a terminal hydrogen, it means what? That it does not contain acidic nature, right? So, for example, now these two, they show acidic nature, correct? Now, I'm going to show you one example like CH3C triple bond C CH3, right? Now look at this. From this carbon, another carbon is attached, and at this carbon, another carbon is attached. So at both the terminals, the hydrogen is not present. Therefore, this particular compound, which is called as your butane, is not acidic in nature. Clear? This is not acidic in nature. I hope this point is very clear to you. So the acidic nature of the terminal alkynes, it is explained by considering the involvement of what? The involvement of this bond which shows S, which is sp hybridized, right? Or we can say that sp hybrid orbitals of carbon atom is formed over here with this, or with this carbon over here, with this carbon, but here we do not see the sp hybridization between carbon and hydrogen, and therefore they do not show acidic nature. Now we should know that an sp hybrid orbital, it has more S character. How much? 50%, as compared to sp2, which has only 33% of S character, whereas sp3 has only 25% of S character. Clear? And we also know that electrons of the S orbital, they are nearer to the nucleus. They are strongly held over there. Therefore, all your RC triple bond C group, they are highly electronegative in character. Is this point clear? They are all highly electronegative in character, and this causes a negative charge over the carbon and a positive charge over the hydrogen over here. Therefore, this hydrogen atom of the terminal alkyne, it behaves as a proton in the presence of the basic species, and therefore we say that the alkyne compounds, they show acidic nature. I hope this acidic nature is well defined to you. Which compounds are acidic in nature and why they are acidic in nature? Because when they combine with the hydrogen terminal, this hydrogen becomes negatively charged and they become positive, and they act as a proton, and therefore they act as a acidic nature. Clear? Now let us understand or see certain reactions to show that the alkynes, they exhibit acidic nature. So let us look at some of the reactions like ethyne Right, what is this? This is your ethyne. It reacts with sodium and it is going to form disodium acetylide, right? That is NaC triple bond Na plus, and hydrogen gas will be given out. Clear? Now, ethyne also reacts with some basic substances and there also it shows acidic nature. So let us see some of the basic substances, like for example sodamide, right? So let's take an example of your ethyne when treated with sodamide, that is NaNH2. So over here what will happen? This hydrogen, the proton of hydrogen, it will be given to NH2, right? And it is going to give out ammonia gas, and therefore we say that ethyne over here will behave as a weak acid. So over here we see it forms what? HC triple bond C Na plus NH3 will be formed. The proton will be given to NH2 and thus ammonia will be formed and sodium will get attached over here. I hope this point is clear. Okay. So over here ethyne, it is acting like a weak acid. Now let us look with propine. One reaction with propine. So CH3C triple bond CH plus sodamide NH2. So over here also the proton of this butane will get attached to NH2 and thus it is going to form CH3C triple bond C Na. What is the name of this compound? This will be called as sodium propanide. Okay, and NH3 will be formed over here. Clear? I hope you are trying to understand this. Now, I'm going to take the next homologous compound of the ethyne group, that is your butane, that is CH3C triple bond CCH3. Now look at its nature with the basic substance, that is the sodamide NH2. Now these two, they are acidic in nature because at the terminal they have the proton over here, but here there is no terminal hydrogen. So this is not acidic in nature, therefore no reaction will take place. So I hope this much is very clear to you. Now next, so that was with the sodium metal and sodamide. Now let's look at the B1, that is action of ammonical silver nitrate solution. Now this ammonical silver nitrate solution, it is also called as Tollens reagent. Okay, so this is your ethyne when treated with your sodium nitrate, which is ammonical, so we need NH4OH over here. So this is going to give you a disilver salt, which is a white PPT. Okay, this is a disilver salt which is a white PPT. Clear? And it is going to give us NH4NO3 plus 2 molecules of water. Clear? Similarly, if we see the ethyne treated with ammonical cuprous chloride. Okay, cuprous chloride. So over here, let's see what do we observe when treated with cuprous chloride, and it is ammonical. So NH4OH, 2 molecules of NH4OH. Okay, so this is also going to give you, now here it was disilver, here it will be dicopper, that is CuC triple bond CCu, and this is your red PPT formed, right? Plus 2 molecules of NH4Cl plus 2 H2O. So I hope till here it is very clear to you. Now let us also understand the difference between Butte 1 ion and Butte 2 ion. How to differentiate between Butte 1 ion and Butte 2 ion. So over here, now let me just give you an example. Distinction between Butte 1 ion and Butte 2 ion. So if I take, what is this? This is Butte 1 ion, okay? And this, when treated with ammonical silver ion, then what are we going to see? AgNH3OH minus, okay? We are going to get a white PPT over here. The white PPT is of silver butanide, that is CH3, CH2, C triple bond CAG plus water and ammonia will be formed, right? And this is what? This is your white PPT formed. What is the name of this? This is called as, this is your silver butanide, right? But over here, Butte 2 ion, it is not going to give you any test. Butte 2 ion means no reaction with this silver, ammonical silver ion. I hope this point is clear. Even if we take ammonical copper ion, then we are going to see what? That Butte 1 ion, it is going to give us a red PPT of copper butanide, whereas Butte 2 ion shows no reaction. I hope till here it's very clear. Now, next we are going to discuss about addition reactions. Now let us talk about addition reactions. Okay, so the first one is addition of hydrogen. So now alkynes, they show two steps. First they form alkenes, and then further addition of hydrogen, they form alkanes. For example, like one bond will be removed, okay, but this reaction takes place in the presence of catalyst. And what are those catalysts? Could be platinum, palladium or nickel. And one bond will be removed and it is going to form CH2 double bond CH2, that is your ethene will be formed over here. Further, if we add more hydrogen in the presence of the same catalyst, platinum or palladium or nickel, then it is going to form alkane, that is CH3, that is your ethane. Clear? Similarly, you can take propane also, like for example CH3, C triple bond CH. When you add hydrogen in the presence of these catalysts, then what are we going to get? We will first get propene. This is your propine. We get propene over here, CH double bond CH2. This is your propene. And on further adding hydrogen in the presence of the same catalysts, we get propane, that is CH3, CH2, CH3. This is your propane. So from alkyne to alkene to alkane, when we add hydrogen. Is this point clear? Now next part of it, addition reactions we are studying. Okay, so one bond is removed and we add the substance. Over here now, let us study addition of halogens. So over here, for example, if we take a propine, that is CH3C triple bond CH. What is this? This is your propine. Now we are going to add a halogen. Suppose I add Br2. So this Br2 can be also written as BrBr. Clear? In the presence of carbon tetrachloride, what it is going to show? As I said, first a disalt will be formed. That is, one double bond will be removed. Ene will be formed because 2 bromine has to be added. So this forms CH3, C, 1 Br will be attached here, double bond C, Br will be attached here, and H, right? So what is the name of this? This is 1,2-dibromopropene is formed. What did I say? First a ene will be formed, and then further if we add, over here I'll write more of bromine in the presence of carbon tetrachloride. Now what it is going to form? It is going to form tetra halide and it will be an alkane. Okay, so it can be called as tetra halo alkane will be formed over here. So let us draw this. It will be CH3CBr. Another bromine will come here with a single bond Br and H. So what is it? It is, I'm writing down the name here, 1,1,2,2 tetra bromopropane. Okay, tetra halo alkane is formed over here. I hope this is very clear. Now this reddish orange color of the solution of the bromine, right, in carbon tetrachloride, it gets decolorized, and this is used as the test for the alkenes and alkynes as well, right? Then next we move to the third type of addition reaction, that is addition of hydrogen halides. The addition of halogen acids to alkynes, it takes place in 2 stages. First, the vinyl halide type structure is obtained, with which is the second molecule of halogen acid reacts and it gives us the dihaloalkanes. Like for example, if we take CH3, the ethyne, right, and suppose I add any of my halogen halide to it. So first what it is going to form? A vinyl halide will be formed, that is CH2 double bond CHX will be formed. Further, when, as I said, it takes place in 2 steps, right? The second step we go ahead adding excess of this hydrogen halide, and then it is going to form dihaloalkane, that is CH3CHX2. Right, so let us see the reaction over here. For example, I take ethyne only. So C triple bond H, right, when treated with HBr. So looking at this compound, you can see the bromoethene will be formed first. That is CH2 double bond CHBr is formed over here. What is this called as? Bromoethene is formed. And then further, when we add more of this HBr, then it is going to form 1,1-dibromoethane, that is CHBr2 CH3, CH3CHBr2. This is 1,1-dibromoethane. ethane. Clear? I hope this point is very clear. Let's take it. This was with ethyne. Let's talk about propane. So CH3C triple bond CH when treated with HBr. Now it is easy for you to understand. Come on, do it. Then it forms CH3C. Bromine will get attached over here. Double bond CH2. What is this? This is your 2-bromopropene. Right? When we add more of HBr to it, then what it is going to give us? CH3, CBr1 and Br2 and CH3. So what is this? This is 2,2-bromopropane. I hope this is clear. So addition reactions are clear to you. Now this was addition of hydrogen halide. Next we shall talk about addition of water. Addition of water. So let us see it with ethyne. That is C triple bond H, right? When treated with water. Now this reaction takes place in the presence of mercury sulfate and H2SO4, right? And the temperature to be maintained is 333 Kelvin. Then it is going to form an unstable compound, that is CH2 double bond CHOH, right? And further on isomerization, it is going to form an aldehyde, that is ethanol, CH3CH double bond O. What is this? This is your aldehyde ethanol. Clear? Let's take one more example. What if I convert this to CH3? Okay. Now when we add water in the presence of mercury sulfate and H2SO4 at this temperature, what is it going to form? It will form an unstable compound CH. Okay, let me write down like this. CH3COH and this becomes CH2, right? Then over here on isomerization, what is it going to form? It is going to form propanone, that is CH3CO, and this also becomes CH3. What is this now? Propanone is formed. So these were your addition reactions. Clear? Now we shall move to, now let's talk about oxidation reactions, right? So first, you already must be knowing about combustion. Over here, acetylene, it burns with the blue flame, and that is used as gas welding, isn't it? You have already done this before. So over here we can learn that the acetylene gas, when reacts with oxygen, what is it going to form? In excess of oxygen, it is going to form carbon dioxide and water will be formed over here. Okay. Now let us understand oxidation with KMnO4 solution. Right? With KMnO4 solution, it is also called as Bayes reagent. Clear? So on oxidation with the neutral or alkaline KMnO4, different alkynes, they give different products. For example, let us talk about the first case. In case of terminal alkynes, what do we mean by terminal alkynes? Terminal alkynes, I mean to say this, if you remember just now I had taught you. Over here, what will happen? The CH, it is going to get oxidized to oic acid, right? For example, let's take But1 ion. So over here, like CH3, CH2, C triple bond CH, right? So over here, when we oxidize it with in the presence of neutral or alkaline KMnO4, it is going to form CH3, CH2, CCOOH double bond O. What did I say? That this CH, it is going to get converted to COOH. So what is the name of this compound? This is called as 2-oxobutanoic acid. Okay. Now, further this can be oxidized. Further this can be oxidized at 373 Kelvin, and it can give us a propanoic acid also. That is, it will give us CH3, CH2, COOH, and carbon dioxide gas can be given out. Right? Okay. Then even your ethene, like CH triple bond, this can also get oxidized in the presence of alkaline KMnO4 or in Bayer's reagent, right, at 300 Kelvin, and this gives us, what is this called as? This is called as oxalic acid. It gives us oxalic acid. Okay, so this I was talking about when we are using terminal alkynes, right? Suppose we are using non-terminal alkynes, then on oxidation, they will show oxidation with hot KMnO4, right? They will not combine with alkaline or neutral KMnO4. The non-terminal alkynes, they will react with hot KMnO4. So let's take an example over here. When I'm talking about a non-terminal alkyne over here, right? So it could be like CH3C triple bond CH3. When it is oxidized, it is going to straight away give us a carboxylic acid. That is, the acetic acid will be formed over here, right? So during oxidation with the alkaline KMnO4, the pink color is discharged and a brown PPT of MnO2 is also obtained, and this reaction is used for the test of your unsaturated compounds like alkynes and alkenes. I hope all the oxidation reactions are also very clear to you. About ozonolysis, that is also included in oxidation reactions. Okay, ozonolysis, this is also one of the reactions which you have already done before of ethyne. So let us do this also. In the presence of ozone, in the presence ethyne, when treated with ozone in the presence of carbon tetrachloride, what is it going to form? It is first going to form an ozonoid, that is CH, which further, when treated with zinc in the presence of water, so it is going to remove zinc oxide, and what it is going to form? CHO. CHO. What is that called as? Glyoxyl, isn't it? CHO. CHO. What is this called as? Glyoxyl is formed. Similarly, we see with CH3C triple bond C treated with ozone in the presence of carbon tetrachloride. Here, what it is going to form? Let's check. CH3C CHOO. Right? When treated with zinc and water, zinc oxide is removed. Zinc oxide is removed. Then what is formed over here? CH3CO. CH3CO, CHO. CHO. What is this? This is 2-oxo-propanal. Okay. So these were the reactions undergoing ozonolysis. Now let us understand the next kind of reaction, that is polymerization reaction, the last one. So linear polymerization, there are two types of polymerization. No? One is linear polymerization and the other one is your cyclic polymerization, right? So linear polymerization can be seen in alkenes, but cyclic polymerization can be shown by the alkynes also, and they form benzene in the presence of red hot iron tube. For example, CH triple bond CH in the presence of red hot iron tube, you can say, in the presence of 873 Kelvin, it is going to form a benzene, right? So these were some of the chemical properties or chemical reactions of alkynes, right? Some of the uses of alkynes are like acetylene. They are used for illumination in the lamps, like we have already studied about oxyacetylene welding gas, for artificial ripening of fruits and vegetables, for the manufacture of acetaldehyde, acetic acid, for preparation of synthetic rubbers, then your plastics, etc. Right? So these are some of the uses of alkynes. With this we finish off with the alkynes now. Next we are going to study about aromatic hydrocarbons, that is arenes, in the next video. Thank you.